Day 335 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1995, count special quadruplets. The difficulty level is easy, but you already know we were going to keep the solution as simple and easy to understand anyway. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. Given a zero-indexed integer array nums, return the number of distinct quadruplets A, B, C, and D such that nums A plus nums B plus nums C is equal to nums D, and A is less than B, and B is less than C, and C is less than D. All right, y'all, that sounds simple enough, but let's go ahead and take a look at these examples just to make sure we're doing this problem correctly. So in example 1, we have the input nums equals an array of integers 1, 2, 3, and 6. The output is 1. Explanation says the only quadruplet that satisfies the requirement is 0, 1, 2, and 3 because 1 plus 2 plus 3 is equal to 6. All right, y'all, so let's go ahead and break this down a little further, right? So as you can see right here, they are talking about the indexes. They're not talking about the elements or the values of those indexes. So if this is confusing you, just know that this is index 0, index 1, index 2, and index 3. And when we add index 0 plus index 1 plus index 2, we get it's equal to index 3, right? And that's what this is talking about right here. When we add 1 plus 2 plus 3, that equals 6. And that satisfies this requirement right here. It says nums A plus nums B plus nums C must equal nums D. So in this case, 1 would be nums A, 2 would be nums B, 3 would be nums C, and 6 would be nums D. And when you add all of these together, you get 6, which is, but then we have to count how many quadruplets. We're not just returning 1 plus 2 plus 3 equals 6. We have to count how many times we're able to achieve these special quadruplets. In this case, there's only one quadruplet that we can achieve, and that's this, and that's this whole array right here, and that's why the output is 1. So let's look at example 2, where it's an example of where there may be 0 quadruplets that we can create. So in example 2, we have the input nums equals an array of integers 3 plus 3 plus 6 plus 4 plus 5. Output is 0. Explanation says there are no such quadruplets in the array 3, 3, 6, 4, and 5. So as you can see in this array, we could do 3 plus 3, that'll equal 6, but that's only 3 elements. That's not a quadruplet, so that's no good. Then anything else, if we do 3 plus 6, that's going to be 9. That's going to be greater than 4, and we could do 3 plus 6 plus 4. That's going to give us 13, which is not 5, right? Because remember, we need these first 3 elements to equal, or we need 3 elements to equal the 4th element. And there's no way we can achieve that by having 3 different elements to achieve or to equal a 4th element. So let's go ahead and take a look at example 3, where there are 4 different ways to create 4 different quadruplets. So in this case, we have the input nums equals an array of integers 1, 1, 1, 3, and 5. The output is 4. Explanation says the 4 quadruplets that satisfy the requirements are the index 0, index 1, index 2, and index 3, which is 1 plus 1 plus 1 equals 3, which is this quadruplet right here. Then the next one is index 0, index 1, index 3, and index 4, which is 1 plus 1 plus 3 equals 5. So it's these 2 ones right here plus this 3 is going to give us 5. Boom. Next, we do index 0 and 2 and 3 and 4, right? Which is still 1 plus 1 plus 3, which equals 5. So index 0 and index is this one, and index 2 is this one. So we take this one and add that to 3, which will give us 5, which is another quadruplet, because remember, the first one we used these two ones. The second time, this time we're using this one and this one. So that's a different combination of ones, which makes it a different quadruplet. And last, finally, but not least, index 1 plus 2 plus 3, index 1 plus index 2 plus index 3 plus index 4 will also give us 1 plus 1 plus 3 plus equals 5, right? So in that case, that'll be this one and this one plus 3 will give us 5, which is a different combination of ones again, which makes it a different quadruplet. And we still add 3 and 5. We still add 3 to equal 5. It's just we're using a different combination of ones each time. We have 3 different combinations of ones we can create with these 3 ones right here, and they are listed right here, and that gives us an extra 3 different quadruplets that we can create. So now that we understand the question, y'all, let's get into the fun part. Actual solutions. Solutions not that difficult. We should be able to get through it fairly easy. So let's get through it. Now we want to create a function to count the number of quadruplets, right? Where nums A plus nums B plus nums C is going to equal nums D. So in order to do that, first we need to create a dictionary to store the sum of pairs of numbers as keys and their frequency as values. So in order to do that, we are just going to declare a variable, and we could call it dict. We could set that equal to a dictionary of integers, so square bracket int colon square bracket. Then we can set or we need to initialize it like that by adding parentheses at the end. Now we need a variable to store the final count of quadruplets, right? Because remember, we're not returning the quadruplets. We're not returning these different quadruplets. We're returning how many different quadruplets there are, right? So in this case, there's 4 different quadruplets. So we're returning 4. So we need a variable to count each quadruplet that we create. So in order to do that, we could just come right here, declare a variable, call it ans, set that equal to 0, and we're good for that. Now we need to initialize the dictionary with the sum of the first 2 numbers. So in order to do that, we can say dict square bracket nums square bracket 0, come outside of that, plus nums square bracket 1. Then we'll come outside that, we're going to say comma default colon 0, and we're going to say plus equals 1. So now we need to loop through the array starting from the 3rd element, or index 2. So in order to do that, we could just say for I in 2 dot dot less than sign nums dot count. We're going to open up the bracket, and we're going to say we need another for each loop, which will be for each I, which will loop through the rest of the elements from I plus 1 to n for potential pairs. So to do that, we're going to say for j in I plus 1 dot dot less than nums dot count. We're going to open up the brackets, and now we need to check if the difference nums I or nums j minus nums I exists in the dictionary. If it does, then we're going to add the frequency of that difference to the result ans. So in order to do that, we could just say ans plus equals dict, excuse me, that should be plus equals, should be an equal sign, dict square bracket nums square bracket j minus nums square bracket I, come outside the square bracket, comma default colon 0. Now we need to come underneath this second for loop, this nested for loop. So we're coming up underneath this one, and we are going to start another loop, and we're going to loop through all of the elements before I and update the dictionary with the new sum pairs. So to do that, we say for j in 0 dot dot less than sign I. We're going to open up the brackets. We're going to say dict nums square bracket j, come outside the square bracket, plus nums square bracket I, comma default colon 0, come outside the square bracket, plus equals 1. Now we just need to return the total count of quadruplets that we have found. So we could just come right here outside of the for loop, outside of this initial for loop, and we could say return ands. Now that should be all she wrote, y'all. Let's go ahead and give it a run. Let's see, and it's accepted, y'all. So let's go ahead and submit it. Make sure it stays accepted after we submit it. See what we're looking like here. Ooh, 7 milliseconds beats 50% of users with Swift though. So not too bad. We can get those numbers up, but we'll worry about getting those numbers up as we continue down our LeetCode journey. For now, we just want to be able to solve the problem that is presented to us. And I feel like this is a good solution for that. Easy to understand so everybody can learn from this solution and apply it later in their LeetCode journey. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.